G'day, I'm Ray Tomes from New Zealand. That's me, the second from the left, on the occasion of attending the memorial conference for Chizhevsky, the famous cycles researcher in Russia, and I'm between the Chancellor of the University and the conference organiser. To the right is Professor Afanasyev, Professor of Geology from Moscow University. At the end of my keynote speech at the conference, he came up to me and put a copy of a book in my hand that he had written. It's in Russian, which I don't understand, and he doesn't understand English, but I looked in his book and I understood that he was happy with my talk because it was theoretical confirmation for the very practical results he'd found of studying cycles in geology over a long period of time. The essence of Professor Afanasyev's method, called the nanocycles method, is that it finds cycles in geological deposits in the varves, the annual deposits made, and these cycles are affected by the moon's orbit, and in particular the upper part here shows the figures used by astronomers for calculating the change in the lunar node precession, which affects rainfall and climate in parts of the world and shows up in geological formations. From the salt deposits in Russia, they have huge records, and the very accurate formula has been devised, shown below, which can measure these cycles and determine the dates of geological deposits from the exact periods of the cycles. In his book he has a very long table showing for by 0.2 million year increments the cycles that appear. So in the first line here, at the current time, there's a 9.298 year cycle shown in geological deposits. If we go back 0.2 million years, it changes a little bit, and as we go back in time we can see this gradually changing. This table runs by 0.2 million year increments to 600 million years. For each cycle, in addition to the main cycle, there are additional cycles due to interaction of the main cycle with the seasons, because rainfall depends on seasons, and these other cycles can be found and help to determine the age of the deposits very accurately. This is a very reliable and consistent method, giving similar measurements in geological formations in different parts of the world. In the nanocycles method book, Professor Afanasyev also shows the different cycles found, ranging from 1 year through to more than 1 billion years. There are particular periods at which many cycles are found. This was why he had enjoyed my harmonics theory talk, because I gave a theoretical basis that showed the same sort of structure. In particular, he has measured very accurately one cycle of 586 million years. This is known in the West as about a 600 million year cycle, but he's determined that it is 586.24 million years, with a very high degree of accuracy from many different deposits. I was already aware of the existence of this cycle from having read the book Megacycles, edited by George Williams, and the proceedings of a geological conference, in which it was mentioned that cycles of about 600 million, 300 million, 150 million, 74 million and 37 million years had been found in geological deposits. What could possibly cause such regular things to happen in geological deposits? There must be something going on in the wider universe that would do this. This graph shows megawalls across space, similar to megacycles in geology. The walls are spaced very regularly and were determined by a joint US and Australian project and the report published in Nature. It gives the distance between these walls as 128 megaparsecs divided by h0. This means that they have to allow for the uncertainty of the Hubble constant to determine what the actual spacing is. With the most accurate Hubble constant that has been determined more recently, this translates into light years as 588 million light years. It seems to me very, very likely that this is in fact a 586 million light years, and that this is showing huge waves in space which correspond with the 586 million year cycle in geological deposits. It means that these waves are oscillating in place, causing both the spacings of supergalactic clusters and of causing the events that lead to geological cycles. This actually allows a more accurate determination of the Hubble constant, because we can apply the two values together to measure the Hubble constant quite considerably more accurately than the present values. This is perhaps a subject for another talk, but the essential thing here is to realize that there is agreement between astronomy, cosmology, the measurement of very large-scale structure in the universe, and the repeating events found in geology, and that these do indicate that there is regularity in the universe on a very large scale, both in time and space, due to standing waves oscillating in place over vast aeons of time.